This is the answer to question 2 of the chapter 11 worksheet. So in this question, I've asked you to calculate the delta G of transport of those electrons from water to cytochrome C. So this is the reverse of what actually happens in electron transport or transfer. But let's go ahead and calculate it anyway. So the water reaction is 1/2 reaction. You find that in the reduction potential table. It's here, oxygen to water. But we're going to go from water to cytochrome C. So we write it this way, water giving up its electrons. And since it's the reverse of the table, we keep the magnitude of the reduction potential the same, but we change the sign. So we make it negative. It's going to hand off those electrons to cytochrome C. So the cytochrome C reaction is going to be a reduction. So iron plus 3 to iron plus 2 is a reduction. We're adding the electrons on the left, so it's a reduction. So we leave this as is. We write it the way it is in the table. So the reduction potential stays the same. You don't change the sign. Now we do need to times this by 2 to get the electrons to balance, because these are 2 half reactions and you need to add them together to do your overall oxidation reduction reaction. There's only 1 electron in the cytochrome C reaction, so if you times it by 2, the electrons will then equal, then you can add them together. So that tells you that N will be 2 for the number of electrons. Now we don't change the reduction potential value even though we're multiplying this reaction by 2. This is an intrinsic value, like density for a compound, so it doesn't matter how much of it you have, you just go with that reduction potential for that reaction. So we don't have to times this by anything. So in order to complete this calculation, we put 2 in for N. We use the Faraday constant, 96,500 joules per mole volt, and then we times it by the difference in the reduction potentials. So once you change the sign, you just add them, and we get a total of minus 0.57 volts. You times that all together, you get a positive delta G that is about 110,000 volts. So since it's positive, it's not spontaneous to run the reaction in reverse. And that's what part B asked. It said, based on your answer, could this process, meaning what we have in part A, run in the reverse? And the answer is no, because the delta G is positive, so it's not spontaneous.